In this video, we are going to review the process of graphing linear inequalities. And this is a review of something that we've already learned earlier this year, but it's important that we remember the details of graphing a linear inequality because we're going to be moving on to graphing and solving systems of inequalities in the next part of this unit. So anytime we're asked to graph an inequality, we need to decide first if our line will be dotted or solid. And if you recall, the way that we will decide whether the line is going to be dotted or solid is by looking at the inequality symbol. And you'll notice here this is an inequality that's in slope-intercept form. And so these values, the meaning of these values don't change. It's the same as what we've studied with equations. So the slope of this line is 4. And the y-intercept of this line is -3. So the first thing that we'll do is plot the y-intercept, -3. And the slope is 4, and we know that means 4 over 1. So that's up 4, 1, 2, 3, 4, and 1 to the right. And then again we continue, 1, 2, 3, 4, 1 to the right. We continue using our constant rate of change to plot points. And you'll notice up here I run out of space. I can't go up 4 again because the graph ends at 8 on the y-axis. So I'm going to come down here and I'm going to reverse. So I'm going to go down 4, 1, 2, 3, 4, and 1 to the left. So I've created the points that I need in order to draw my line. But now what I need to look at is the fact that this symbol is greater than. Okay, and so if the symbol is greater than, or if it says less than, if you remember, that is going to result in a dotted line. So if it's a less than symbol or a greater than symbol, your line will be dotted. If the inequality symbol was less than or equal or greater than or equal, then we would have to draw a solid line. Okay, so we're going to draw a dotted line. Do the best that we can. Sometimes it's difficult to do on the iPad. Okay, so there is our dotted line for y is greater than 4x minus 3. Now the next thing that you need to remember is we have to decide where we should be shading. Okay, and so if you remember, we need to use the test point, and the test point that I have suggested that we use is 0, 0. So 0, 0 is here. It's on this side of the line. So we're going to plug in 0 for the x value and 0 for the y value, and we're going to see if those values actually satisfy this inequality. Okay, so we're going to plug in 0 for y, 0 is greater than, 4 times x value is also 0, we substitute, and then we copy the -3. Okay, and now we have to simplify, 0 minus 3, over here we bring down 0, so we end up with 0 is greater than -3, and we have to ask ourselves, is that a true statement or a false statement? 0 is bigger than -3. That's true. And so since it's a true statement, what that tells us is this point right here, 0, 0, that is a solution to this inequality. And we always want to be shading on the side where the solutions exist. And so in this situation, in this case, we're going to be shading over here. We're going to be shading to the left of the line. Okay, so dotted line and shading to the left. So this would be the graph of the inequality y is greater than 4x minus 3. Okay, so let's take a look at another one, and we'll move a little bit more quickly this time. So we have y is greater than or equal to -2 over 3x plus 5. So we know that's our y-intercept, and that's our slope. So we have y-intercept is 5, and our slope is -2 over 3. So I'm going to go down 2 and 3 to the right. And I don't have any more space, so I'll go up 2 and 3 to the left. So those are the points that I'll need to draw my line. And now I need to take a look at the symbol. This symbol is greater than or equal to, which means that we need to draw a solid line. So I'm going to draw a solid line passing through those points. And the next thing that I need to do is use my test point, 0, 0, So I'm going to plug in 0 for x and 0 for y. So I'm going to have 0 is greater than or equal to negative 2/3 times 0 plus 5. And this is a great example to illustrate why 0, 0 is a good one to use as your test point, because no matter what our slope is, when I do that multiplication, it's always going to come out to 0. So it kind of helps me to make my calculations a little bit easier. So I end up with this inequality. 0 is greater than or equal to 5. And that is false. 0 is not greater than or equal to 5. And so what we just figured out, if we get a statement that's false, what that means is that this point 0, 0 is not a solution to our inequality, which means that I cannot color on this side. I can't shade on this side because it's not a solution. What that tells me is that the solutions to this inequality have to be on the other side of the line. And so that is where I need to shade. Okay, so I'm going to shade over here. So this graph is the solution, or this graph rather is the graph of this linear inequality. Y is greater than or equal to negative 2/3x plus 5. Okay, and one final example, we have y is less than or equal to negative x minus 2. And again, this is in slope-intercept form, so here's our b value. And it's important that we recognize our slope is negative 1. So the b is right here, negative 2. And a slope of negative 1 results in points headed in this direction. So we'll go as far as we can up this way, and then we'll reverse it and we'll go down 1 and 1 to the right. And now we need to think about our line. We have the symbol is less than or equal to, and so that results in a solid line. So I draw my solid line. We always remember the arrows on both ends. And now, as always, with graphing linear inequalities, we need to think about the test point. So I'm testing out to see, is this point right here a solution? If it is, then I have to color on this side. I have to shade on the side of the solutions. If this point, the origin 0, 0, is not a solution, then I'm going to shade on the other side. So let's see what happens. Plug in 0 for y, so I have 0 is less than or equal to negative 1 times 0, and then minus 2. Bring this down, bring down our symbol. Negative 1 times 0 is 0. Bring this down again. 0 minus 2 is negative 2. And this says 0 is less than or equal to negative 2, which is false. So what I've just determined is this point 0, 0 gives me a statement that's false, which means this point is not a solution, which means I can't color on this side. I have to color on the other side. So I'm going to be shading here. All of the solutions to this inequality exist over on the left.